Thank you for inviting me to this great conference. And yeah, I really want to say something about science, but yeah, Will Oliver is supposed to give something really nice about superconducting qubit, and it's so boring because it's not superconducting qubit community anyway. And another thing is, usually science we are doing is proving that my qubit sucks. Why we figuring out why my qubit is so bad. That's a science. Yeah. So instead, I it's another science talk. Uh, it's not science talk. So we should. I'm giving you some story we had worked on for last 2 years about what quantum computer is, how to persuade people to do quantum computer or not to do quantum computer, and making kind of consensus what's quantum computer, what's not quantum computer, something like that. So that's pretty much similar to what Andreas gave talk at the beginning of this conference. Uh, we don't have any nano here because it's mostly done by so-called old quantum community. Yeah. Okay, so basically I'm talking about two things. One is about the quantum computing strategic planning, which is making us just a less than 100-page document to be readable to the policymakers, non-scientists, which was done in 2017-18 by our institution scientists, Chris members. And at the end, maybe I spent 5 minutes to introduce what's going on in Chris about superconducting qubits. So this is the document I'm going to explain. Everything is in Korean. It was supposed to be Korean. And the contents contains like background, overview, the research status abroad, domestic, industry market forecast, which is really silly, but it is there. Because this is kind of a standard format that the government officials want. They want to do it. And it should be written in Korean. That's important because we already have plenty of documents around. If you Google, you have many documents about technical or policies, but they are all written in English and they are written in UK, in the US, in China, in Japan. It's their view. We can translate it into Korean, but we haven't had anything on our voice, so we really wanted to like make something. So who worked on it? So I persuaded my colleagues, scientists, seven including me, to work on it. The request came to Chris maybe early 2017 because there are many program trials in 2015, 16, all failed because there was no consensus among scientists and also among the politicians too. So they asked me to study a little bit about quantum computing and to make it readable, not too technical, but not like newspaper things, so something in between. So I persuaded that they are real research scientists. So none of these 7 people have done this kind of thing before, and maybe never again. We really do. They promise never again. So they are usually the real research scientists staying most of the time in underground labs. Our labs are all underground, so, and they never want to go back to the overground again. So, so we have 2 people from quantum optics, and we have 2 persons from cold atom, mostly atomic clock and BEC guys, and we have 2 people from solid state qubits. And these people, and including me, are kind of close to quantum nanoscience field. Juno was from Keith Schwab's group from Caltech. Jaehoon used to be a postdoc with Jeff Kimball. Hisu once worked with Paul Kwiat, so they have some connection with the US research scientists. And also, the important thing the government officials emphasize every time is that this is the opinion of a Chris scientist, not the government. That's true. They ask similar thing to many communities, many research institutes. So they are collecting opinions of every stakeholders, every person, and they read through them and they make some decisions in the end. So if we make a good document, is to be read. If we make a bad document, then it will go to the trash can. So we have to make it well. So it should be written in Korean. That's important because nothing was there. We have to collect the voices of domestic researchers, of course. It cannot be a full consensus at the beginning because this is the first try about quantum. The goal is the weekly scientists are expert, we know, but we listen. We just write down, summarize, unless it is false. So as long as it's a fact, then we write down. We don't talk too much. Documents should be written in Korean, not too much technical, but should have a technical contents in it, have some depth, not too deep, to be read by public and also policymakers. Based on publicly accessible documents only, non-published secret front data is not included. And that's the important part. We really want reviews or comments from the foreign researchers who can speak Korean. He can be American nationality, UK nationality, but who should be Korean origin, so Korean American, Korean German. So those people, we asked 10 of Korean research scientists abroad. And at the end, we are supposed to suggest a plan, which may be a bad plan, whatever we can make as best as we can. We have to make a plan. Who participates? So we just asked the scientists in Korea. Usually, most scientists were reluctant to do that because this is not science at all. So, but anyway, we successfully proceeded 30 people, about 10 from quantum optics and theory, about 10 atomic, and 10 from device and quantum nanoscience like things. And so half of them are from academia, professor, government lab 12, 2 from industry, 1 from SK Telecom, 1 from Samsung, and optics, atoms, devices. And this is really interesting. Somehow the age of the quantum people is not really randomly uniform in terms of age, generation, but they have some peaks around some age, I cannot tell. So we really try to make kind of a generation to generation mix among Koreans even. And we divide them into 3 topical committees: optics theory, atom ion device. It doesn't have any weight or focus, but it just divided into the number of people in Korean community. It represents the size of the community in Korea. So optics plus theory, atoms, ions, and device, and etc. That means etc. is about the same size in terms of community in Korea. They have kind of 4 times meeting per committee, and we wrote a rough draft, and we sent it to 10 foreign Korean-speaking research scientists. Some want to be anonymous. Some said okay. Jung Sang Kim was one of them. He want to have his opinion in really. So it's the Jung Sang Kim and 9 others we wrote down. And also we usually have this kind of meetings in Korea. So when we have this kind of meeting, we go there and we ask some of the real experts. For example, if we want to hear some comments about superconducting qubit, hey, Will Oliver is coming. So then we just call Oliver before, and then, hey, Will, could you help us to talk about, maybe let's have a coffee chat, maybe 2 hours, and then we just explain what we have done, draft, and we would like to listen. So we had such a kind of thing 4 times. Ivan Deutsch was here. Paul Yasan was there. Yasu Nakamura was here. Robert Hadfield from Glasgow was here. So they gave us some input. And we then got some feedback from Korean domestic people, and then we finalized. Okay, and that was finalized about at the end of 2017. In 2018, we finalized the draft, negotiating with the government officials, real politicians, non-scientists, And in the end, we have a kind of symposium. We called it Global Quantum Computing Technology Symposium. This name really came from the politician side. They really want to call it global. So, so we invited 8 people, including Jong-sang, and Isaac Kim was here, and Do-hwan, Ki-hwan, also ion trappers and semiconductor guys and theorists, and he is a real computer architect, computer scientist, and he is a neutral atom guy. So they gave a pretty good talk, and actually one of the congressmen came here, but he is not a real congressman. Congressman slash physicist Sejong-oh was there. And also, actually, there are very high-level policymakers attended the conference. That was pretty successful. So this is what the document is about 100 pages. It's an open document. It's distributed everywhere. So if you don't have it, you can get it PDF or really printed form. So these are 3 things they were discussed. So most of the contents are really trivial to us. To us as scientists, it's really trivial, but writing it down in a written form is a little bit tricky. And also the opinion of each scientist from each sectors are really different. So first thing is, what is quantum computing? So it's a computing technology. It should compute something, use quantum mechanical effect, and for problems which are very difficult or impossible for digital computers. This is so plain that there's nothing special, but writing and choosing each word took half-day meeting or twice of half-day meeting. We would like to define what qubit is. Having 2 quantum states is never sufficient. That was really hard to get consensus, because most of people want to say that my system is a qubit because it's quantized. No, quantization doesn't mean qubit, so you need really coherence and quantum control. And the other extreme side is, hey, your system is not sufficient for qubit because you don't have any entanglement. So entanglement and ensemble. So Andreas exactly mentioned what we had 2 years ago. Ensemble and entanglement was really tricky word they are discussing about. So they are not included here. But coherence only is not enough. That's what they said. It's not my opinion. So quantum control should be there. It should be controlled coherence. And at the end, what is quantum computer? So collection of qubit does not function as a quantum computer. That's so obvious, but because they are always talking about 53 qubit systems, 72 qubit process, Bristlecone. So the number of qubit doesn't matter too much. So the definition is mostly from the quantum optics community that the computation space should scale exponentially. So linear scaling doesn't matter. So this is kind of simple conclusions. And we just searched the current status abroad. It's so easy. They have all some programs, some status. 2 years ago, it's easy. Domestic one was a little bit hard. So we collected informations, written down, we circulated draft, and we got really hard feedback that many people think that their work were underestimated or missing, or they think their work is quantum, but somehow from the committee view, it's not quantum, something like that. Nano is a taboo word. There's not a single nano in this whole report somehow. So it's not a science problem. I think it's a people thing. But in the end, we made a roadmap that so it's kind of 4 category the committee suggests to do. It's so simple to us, but writing down, get a consensus is also very hard. Universal quantum computer up to 100 qubit scale, and error correction should be tried somewhere here, above 20 qubit scale. Quantum simulator should be done, but it's not about the size or functionality. It's the problem, what they really want to solve. The meaning of the problem is important in quantum simulator. And then algorithm supporting components, and then next generation technology. That means just nothing. Everything you want to suggest as quantum computer is possible here. So there are 4 categories there. And we went out for the expert reviews in foreign countries and written form and online, offline. And we got really good advices. First, we don't have people. Everyone knows Korea is lacking the manpower. So we have to educate people as soon as possible, make an ecosystem. We don't have any components, even lenses or amplifiers, even connectors. They are all imported. It's not good. Second thing is investments should be really statistical, no random investment. But uh, right now we have to do fast followers. Two-track is a really key word here because there is a large milestone-oriented research should be there, but also there should be a bottom-up at the same time in parallel. Suggest milestone, bring foreign reviewers. That's also very, very important message from all of the reviewers. Korean community is just so small, so everyone should be a player, and they cannot be a reviewer or planner at the same time. So you should bring reviewers from outside, and the money size should be the right size, not too much, not too small. Right size is a really fuzzy word, but there is a consensus. But and yeah, timing should be important, something like that. So that was so trivial, but also it's written, not by my voice, but the expert's voices. It's the same thing, so we just summarize things. This is typical Korean government officials format. It has a specific font size, line spacing, colors. So, and this they can read. If you write down this in Times New Roman, size of 10, it's not readable. So it's a pain. It's not a science job, but we did it. But somehow we resubmitted it in the summer of 2018. So I think it was August, September. And they have several other reports there, but somehow they accepted most of the part. They accepted other parts from other reports, I think. So they just mixed them together, blah blah blah. And at the end of the year, they submitted some budget request to the Congress, and they got some money. Yeah, and this year the NRF is the funding agency, and like NSF of Korea, So they launched the quantum computer program. The size. Oh, I should have written the size. The size is about 4 million, 4.2 million, 4.1 million dollar. No, $41 million per 5 years. It's like something like that. It's 40 million per 5 years, and they just categorize these 4 categories. So universal quantum computer, it's specifically written there that we should demonstrate something 5 qubit scale system with 1 qubit fidelity 95, 2 qubit fidelity 80, etc., etc. It's really, really written down in detail, and they announced they will select 3 projects, 3 plus 2 years, so total 5 years. And second category is quantum simulator. It's really broadly written. You should propose and solve a useful is really fuzzy, but useful problem. And it should show some quantum advantage or something quantum. And any platform is okay. So because I'm also a player, so after writing the documents, I was out, so I don't know how these are written in detail, but anyway, many people involved in the writing of this. And also there is the third category called quantum computing system technology. They announced 4 projects, 3-year, architecture, control, and optimization, benchmarking, blah, blah, blah. And there is algorithm and theory category. So first 2 categories, they written down everything in detail. Second category, it's basically top down. There is no restriction. The good thing, we had 2 excellent foreign reviewers. Yasu Nakamura and Barry Sanders came here, and they reviewed the proposal for 2.5 days. They did a really good job. They reviewed it really hard. And the final selected projects were announced yesterday dinner time, when we had dinner. Okay, so, and I will really briefly introduce other programs. There is a ERC program, engineering program by NRF, again the same funding agency, from the electrical engineers. They really want to make all the electronics for cubic control. They want to make agilent circuit out. It's designed for qubits. There is another program called quantum sensing from the other funding agency. They are having gravitation, single photons, imaging, and magnetic sensors, and so those things are also going on. This is about $22 million per 4-year project. And also there are some educational centers for quantum. So there is one quantum communication education center in Korea University. The other one is KAIST, this Quantum AI Center. Yeah, I couldn't find any details about those centers yet, but okay. I'm from CRIS. CRIS is a standard lab doing all the standard measurement, precision measurement for those physical properties. And it's basically Korean version of NIST or PTB. This is our lab. We are running basically dilution refrigerators, and we do qubit research. And the main purpose of this research is basically we really want to do everything in precision. And we are standard lab. We are not yet going to the scalable quantum computing, but we really want to do precision control, good qubits, and characterization things. So we have pretty nice fab. So we are doing wafer scale fabs. Usually from design to chip is less than 1 week, theoretically. We have pretty good chip yield. Our chip yield is almost 100% without any dirt on it. The spread is 1 sigma of about 3% at best. We run circuit QED systems, and we usually work on 3D transmon, so 3D cavity plus transmon chips. And we usually put multiple qubits in the same cavity. That's kind of the easiest way. We have pretty good coherence. So yeah, in terms of T1, it's about 100. T2, we never get over 100, but T2 is usually some tens, 50, say. Mostly we focused, for the last 2 years, we focused on benchmarking, process tomography, control optimizations. And now this is the selected project announced yesterday. We were selected out of the 12 projects. So we will make something 5 qubit-ish. So I asked about 12 professors across Korea to join. So there are many universities there. Yeah, so I'm there. He is an expert in 3D integration, TSV thing. I have a HEMT amplifier, cryogenic amplifier expert here. Young Lee is a SQUID expert. And we have a theoretician, Mansu, from Korea University, and he is doing quantum algorithm, Junseok from Sungkyunkwan. So that's about what I would like to talk about, the story, how quantum computer program has set up for the last 2-3 years. And because the message I really want to say within half a minute right now is, because this quantum computer program really want foreign reviewers. This year, they succeeded only 2 reviewers because there was a limited time. But if you are all experts, and I'm pretty sure you are in the kind of pool of the reviewers in NRF, and if you have some call, please come and give us some hard review and advice so that we can upgrade our community a little bit better. Otherwise, we cannot survive because this is a small community. So I'm a player, I'm not a reviewer. But I can be a reviewer, another player, but the number of people in Korea is not 100. So please come, that's my message. For domestic researchers attending this conference, please give some input. These kind of things, I will never do that, I promise. I will never do this kind of silly thing, but somebody really asked to follow this, because when you don't like this kind of documents, and when you don't agree the points we made, you can fix it. So it's open to everyone. Thank you.
Thank you very much. Yonuk.